All right, we're looking at our next optimization example. It says a rectangular beam will be cut from a cylindrical log whose radius is 15 centimeters. All right, so we've got a cylindrical log. I did a cross section here. The stiffness of the resulting beam is proportional to the width multiplied by the cube of its depth. All right, so W for width, D for depth. Determine the width and depth that will result in the beam with greatest stiffness. So we are maximizing this. And then if you look at your constraint, if you call the center of this cross section C, the distance from the cross section to the edge of the circle would be 15 here. And so if you go all the way across, this would be another 15. And so on the other side, we've got my constraint, be the Pythagorean theorem. All right, so 15 plus 15 would be 30. 30 squared equals W squared plus D squared. All right, so if I solve for D, I get 900 minus W squared inside of radical. Right, this will be a positive distance because this is a rectangle. All right, it also tells me that my my domain would be 0 to 30, and because this is a, oops, sorry, this would be a triangle, right? And then 30 would be the biggest side, would be the hypotenuse. All right, so that's the things I'm looking for, right? A function in terms of one variable. I'm about to do that. Oops. Right. Square root of 900 minus W squared for D. Right. So we have a function in terms of one variable. We've got a relevant domain. Next thing we're looking for is a critical point. So first off, I'm going to simplify my my function, right? Square root is 1/2 power. Take it to the third power, gives me 3/2. Right. So now we do product rule to take the derivative. Right. And then the second part, going to use the chain rule. All right, so let's see. Oh, that should be a 1/2 power. You have to decrease the power by 1. All right, so the first term, it's just square root of 900 minus W squared. All right, I'm going to put it back to that. Yeah, maybe I won't. Backtrack here. Let me erase that. Just keep that 3/2 power. All right. And then on the other side, we've got a negative 2W, negative 6W squared times the square root of 900 minus W squared. Sorry, I keep doing the square root and keep it as an exponent. All right, so now what I can do is I can pull out that 1/2 power. Right, if I pull out a 1/2 power from the second, I just get minus 6w squared. If I pull that out of this, let me make sure I'm doing this correctly. Oh no, so it should just be a 3. Right, 3/2. I forgot that denominator. Right. So in this case, this 2 and this 2 cancels each other, so you get a negative 3w squared. Okay. So if I pull out a 1/2 power out of this, what you do is you subtract the exponents. So 3/2 minus 1/2 gives me a first power. All right, so this is the square root of 900 minus w squared. This is 900 minus 4w squared. All right, this part's going to give me critical points at plus or minus root 30, which is not in my interval. Right, my domain is not including root 30. This is going to give me, let's see, 900. I think that's 225. All right, so 15 would be my critical point. Okay, so that's the third thing I'm looking for. First thing is function with one variable in it. Next thing is domain. Next thing is critical point. All right, so now we check. We have a max. So we look at your number line. 0 to 30, my critical point's at 15. So we're going to pick representative points. Let's say 1 and maybe 20. Plug it into the first derivative. All right. So this is the simplest version of my first derivative. So I'm going to plug it into that. All right, so square root 900 minus x squared times 900 minus 4x squared. Okay. For positive 1, I'm getting a huge number, 26,865. Ultimately, I care about the positive. For 20, I am getting a negative 15,652. So we do get that maximum from the first derivative test, right? Increasing, critical point, decreasing. So max at 15, which is what I'm looking for in this case. Finally, actually answer the question. It's asking what is the width and depth. So the width here is 15 centimeters, and then the depth, if you look back at your d variable, is this right here. Square root of 900 minus 15 squared. Right, so this is root 675 centimeters. So that would be my final two answers.